Right, hi guys. So as promised, we're now going to look at exothermic reactions and their energy profile diagrams. Okay, you'll remember that exo, you should now remember that that means exit, and that thermic means heat. So these are the reactions that give out energy. We looked last time, and I'll do a brief sketch just again to remind you that we had a Bunsen burner and we had it set on fire. Okay, and we talked about what's going on here, that we've got energy released to the surroundings, okay, and it's methane and oxygen that are being reacted together. Okay, so it's a combustion reaction, and that is an exothermic reaction. Okay, so we've looked at energy profile diagrams for endothermic reactions. And if I draw the same kind of diagram again, okay, I've got progress of reaction, and I'm going to just put Rxn, which just means reaction, it's just my shorthand for that. And then here we've got energy. Now, with an endothermic reaction, if you remember, we started with the energy of the reactants at the bottom. Okay, and we had the energy of the products at the top. We did this loop. Okay, this part was the activation energy, and you can see that because there's a difference in the amount of energy of those two sets of chemicals, the reactants being lower than the products, this amount of energy here has to come from somewhere, and so it comes from the surroundings. So you get a temperature drop. Now, what you probably don't need me to tell you now, hopefully you'll have worked this out, is that we now have the situation where actually our reactants are at the top, reactants, and our products are down here, P. So that means that when we start the reaction, okay, we need to give it a bump of energy, okay? And if you remember, this is called the activation energy. And that's really important, actually, just as another little part of your chemistry knowledge. That activation energy there is basically you having the lighter or a match and lighting the Bunsen burner. You're giving it a bit of energy. But with an exothermic reaction, because you have energy released, the amount of energy released is enough to start another reaction. It's almost like a chain reaction that you'll have learned about in physics. So once you've started that reaction, you'll create more reactions after it until you cut off either the supply of methane or the supply of oxygen. Okay, and you do that obviously by turning off the gas tap. But that activation energy, obviously, if you just mix methane and oxygen, it doesn't react. You get no reaction whatsoever. Okay, until you provide some energy. Now, I don't know if you'll know this or if you'll remember this from kind of gas safety training or whatever. But if you go into a house and you can smell gas, one of the big pieces of advice I remember from 1980s safety videos is don't turn the light on. Because if you turn the light on, that little spark of energy sometimes you get from turning the light on, the electricity flowing, you sometimes create a spark, and that can be enough to start an explosion if the gas mix is right between the oxygen and the methane. Okay, and that is again just providing activation energy. Okay, so this is not just a chemistry lesson, it's also a gas safety lesson, guys. So don't go into your home, if you smell gas, don't turn your lights on. Just leave the house and call your mum or dad, right? Okay, and so on with this. The amount of energy released then is this part here. Okay, energy released. Okay, so this amount of energy, as we looked at in the last lesson, okay, is for this specific reaction where we've got methane and oxygen here, and we've got CO2, carbon dioxide and water here. Okay, that amount of energy released is 882 kilojoules per mole. And you'll remember, hopefully, that because we've got that minus sign means energy released. It is because the chemicals have gone from this amount of energy, they've got all of this energy up here, and some of it's been released, so they're losing energy. And that's what we're talking about. We're always talking about the energy from the perspective of the chemicals. Okay, it's really important that you guys remember that. Okay, so that's all that we've got for today. I hope that you understand exothermic reactions and their energy profile diagrams. Stay safe, and I'll see you next time. Bye.